Exactly 30 days ago, a brand new, completely faceless YouTube channel named Zen uploaded its very first video. Look at this exponential curve graphing the channel's initial performance. In a single month of existence, it accumulated 14 million views and generated an estimated $61,000 in revenue. Typically, producing 12 highly visual videos in that time frame requires endless hours searching for stock footage, cutting clips, and manually syncing images to a voiceover on an editing timeline. But the creator behind Zen didn't sit in front of a monitor cutting clips for weeks. Instead, they built a machine to do the assembly for them. By utilizing a specific network of AI tools, the standard 20-hour workflow to produce one of these videos compresses down to roughly 20 minutes. The process relies on three components communicating with each other: an automated transcription tool, a localized command line AI, and an image generation skill. For a channel like Zen, the bottleneck shifted. The primary effort moved from manual video assembly to the architecture of the production machine itself. Every automated machine requires raw material to function. For this workflow, the process begins with a completed audio file of the script being read aloud. That voiceover file is uploaded to a transcription platform called TurboScribe. This diagram shows TurboScribe translating an audio waveform into sentences paired with exact timestamps. These text blocks feed directly into Claude Code's local terminal window. To generate image files, the AI integrates a new software node, the Higgsfield AI Skill. A few simple terminal commands link these pieces together, establishing a continuous flow of data from the initial script directly to the image generator. By connecting time-stamped logic to a localized drawing tool, a standard text AI is retrofitted into an automated production studio. To operate this studio, the creator uses a specific set of instructions known as the master prompt. This process flow shows the master prompt splitting into two strict directives. The first rule forces the AI to draw every image in a crude MS Paint style, maintaining visual consistency. The second rule commands the generation of exactly one unique image per timestamp. Claude executes the Higgsfield Skill, autonomously batch-generating hundreds of visuals in minutes. Crucially, the system names every newly saved image file identically to the numerical timestamp it was created for. The creator opens their editing software and drags this generated folder of images directly onto the timeline. Because the file names are numerical timestamps like 0.07, the images naturally organize themselves sequentially, landing perfectly in sync with the audio. A file naming protocol replaces the manual labor of cutting and syncing clips, reducing hours of tedious timeline work to a 10-second drag-and-drop action. When you look back at one of Zen's completed videos, the magic dissolves. You are simply watching time-stamped logic executing exactly as programmed. Generating tens of thousands of dollars in 30 days ceases to look like a viral accident. It is the predictable output of a perfectly tuned mechanical system. In this specific workflow, technical execution is no longer the primary labor cost. The assembly is handled by the localized software. The human role in this automated era shifts towards the quality of the core idea and the depth of the initial script fed into the machine. The adoption of this architecture allows a single person to manage a volume of production that previously required a dedicated team. The engine is functional. Its only requirement is a cohesive script to execute.